Good morning, my dear J 2025 warriors. Yet another session of your Think Different series, which forces you to think very differently. And the questions are very unique in this particular session. And today's session has some really killer visualizations. Okay, so let's begin with the class with your none other than Captain Shreyas. Welcome, Vivid. Hi, informative tech. Welcome, Carleven. Good morning, everyone join it to the class because the class is going to be really amazing. All right, so I hope I'm audible and visible to all of you. So let's begin. And before we progress ahead, make sure that you are liking this video so that you get more amazing such content, because it takes a lot of time. If you show your support, more sessions will come. Okay, and stay subscribed till the end of JEE Advanced. So here comes the first question on your screen. There is a wire in the form of a tetrahedron. Wow, okay. And the resistances of each edge. So you can see there are 1, 2, 3, 4, 5, 6. 6 edges are there of this three-dimensional tetrahedron. Each side has a resistance R. Then the equivalent resistance between the corner 1 and 2 and 1 and 3 is what? First things first, you can directly eliminate few options. Can you guys quickly think and tell me which options can you eliminate directly? Hello, Harni, good morning. Yes, bring your books. Hi, Sai, good morning. Vivid, the class has started. Yep, hi, Sukuna, good morning, everyone. I'll tell you how you can eliminate the options. Yes, in advance also you can eliminate options. It's very rare, but you can. See, over here, tetrahedron, first of all, is a, where is this? A tetrahedron is basically a symmetric, three-dimensional figure. So any 2 points you take are identical. Whether you take this point and this point, this point and this point, this point and this point, this and this and that, this and this, any 2 points is identical. It's not like a cube. See, what happens in a cube is that if I take the resistance between these 2 points, it is different than these 2 points. It is different than these 2 points because all the points are not going to be identical. You will find different paths and different resistances across them. But that is not the case over here. The moment I choose this point and this point, or whether I choose this point and this point, it is one and the same thing, guys. It is one and the same thing. So the resistances should be the same for 1 and 2 and 1 and 3. So based on that logic, can you see there are only few options like that which have same options, which have the same options. Which are they? Yep, R by 2, R by 2, RR. This and this is definitely not correct. So obviously option C gets eliminated and option D gets eliminated just because of symmetry. What is it? Just because of symmetry. So either it is R by 2, RR, or whatever it was, it should be similar. It cannot be different. Is this point understood, everybody? Quickly let me know. So now you have to just solve only one problem, not two problems. Okay. Now let's do something. How do we solve any one of them? Actually, here onwards also you can eliminate. I'll tell you how. See guys, between 1 and 2, okay, there is a resistance R. Between the points 1 and 2, there is this side R, and the rest of the resistances, or whatever is there, the rest of whatever the resistances which are there are in parallel. So whatever happens in a parallel combination, what happens in a parallel combination? The equivalent resistance, in parallel is less than each resistance, That means the equivalent resistance between 1 and 2 must be less than R. The equivalent resistance between 1 and 2 must be less than R. So which are those options? Which are less than R? This is equal to R, so this is out. So the only possible option is R by 2, R by 2. And let's figure out whether it is actually correct or wrong. Yes, it is. Oops, what just happened? Yes, it is correct, guys. R by 2, R by 2. Did you see, without solving and just elimination? But it is a very tricky and smart elimination. But don't worry, I'm not going to solve the problem like this, especially for a JEE Advanced. This was just to show you that there will be certain questions which you can think little differently and eliminate the options. This was a very, very, smart way of doing it in very special circumstances. But let's say there was one more option which said R by 3, R by 3. Then you are in a complete soup. Then you cannot eliminate it because both R by 2, R by 2, R by 3, R by 3 follow both our criterias. They are symmetric and equal, and they are less than R. So in that case or situation, you will have no other choice but to solve the problem. Is that right? Okay. But how do we solve them? See, first of all, as you can see, between these 2 points, so the current is coming like this and it is going out like that, 1 and 2. I feel point 4 and 3 are equipotential. Can you see that? The current goes to 4, it goes to the current goes to 4, it goes to 3. The current goes to 4, it goes to 3, it also goes to 2. But here also the current is coming from 4, it is coming from 3. You can see that there is actually a plane of symmetry if you visualize it properly. Yes, there is a plane of symmetry out here, which is little tricky to show, but I will try my best. I will try my best to show it to you. Okay, I'll just try my best to show it to you like this. See if you're able to visualize this. This is the plane of symmetry which is there. Check this out. This is that plane of symmetry which is there. This is that plane of symmetry, the plane of symmetry which is there, and on that plane of symmetry all the points are equipotential. That means the potential of point 4 will be the potential of point 3. So whatever resistance is there between them, just ignore that. Just ignore that particular resistance. So our equivalent circuit will be something like this. To 1 and till 2, there is only one resistance out here, which is R. So this was your point labeled 1, this was point labeled 2. And then show the other resistances like this one and this one. Do not show 4, 3. Do not show 4 and 3. So from 1 to 4 and 4 to 4 to 2. Yep, these are two resistances. And 1 to 3 and 3 to 2. 1 to 3, 1 to 3 and 3 to 2, like this. 3 to 2. Yes, this is what it is. This is also resistances are. Now, can you see there are actually 3 branches out here? Can you see that there are 3 branches out here? 3 branches out here. I have reduced the circuit to this. And what are those 3 branches, guys? Between 1 and between 2. The first one is obviously this resistance R. The second one is these two resistances in series. So the equivalent resistance will be 2R and another two resistances in series. So again, you will have basically 2R in parallel with it. So I have eventually reduced the circuit to 3 resistors in parallel. So I can just find out the equivalent resistance in a very easy way. 1R12 reciprocal will be 1 by R plus 1 by 2R plus 1 by 2R, which is nothing but 1 by R. Half plus half is 1 only, so it is 1 by R, which is nothing but 2 by R. Take reciprocal of it, so R12 will be R by 2. Hence, R by 2 is the right answer. So, first of all, whenever circuits have some symmetry, all the points on the plane or line of symmetry are equipotential. Any device between them will be ignored. So the device between them is this resistor that I can ignore. So I have one resistor between 1 and 2, which is that pink one. Then you have 1, 4 and 2. 1, 4 and 2. Yes. And then you have 1, 3 and 2. 1, 3 and 2. That's all. So these are the only resistances that will be left out. That's it. And all of these are three parallel branches with resistances R basically in series. So 2R, 2R, and this R are in parallel. So find the equivalent using a standard formula. Is this understood, everyone? Clear? Yes, Vijay. We will be making a very important mock test with most expected questions very soon. That plane of symmetry part, okay, you'll have to visualize a tetrahedron. You will have to visualize a tetrahedron. You would have seen it in your chemistry class, right? So tetrahedron, guys, is something like this, okay, like a pyramid structure, okay. And just imagine, this is point 1, this is point 2, this is point 1, this is point 2, okay. The third side is behind it. If you are not able to see it, I'll just probably show it like that, okay. All right, so this is our tetrahedron. This is point 1, this is point 2, this is that you know, this is the points which are behind, like this. So there is a plane which cuts, there is a plane which cuts in the between, which keeps everything symmetric. So just think about it. This is point 1 and 2. There is a plane which cuts. Visualize this in three-dimensional. So point 2 is on the right side, point 1 is on the left side. Okay. 4 and 3 are on that plane, but not one below the other. 4 is slightly in the front, 3 is slightly behind. Now are you able to visualize it? So whatever is there on the left is there on the right. That means all these points must be exactly at half the potential. If this is 0 volts, this is V volts, this will all be at V by 2 volts. This will all be at V by 2 volts. If this is 0 volts, this is 100 volts, 4 and 3 will be at 50 volts because it is midway in the circuit. Are you now able to visualize it? Yep. Yeah. Doing by Kirchhoff's loop law, can we do it? Yes, you can do it, but it will be much lengthier because there are so many branches. 1, 2, 3. Here also there is splitting. It will be a very difficult problem. Whenever symmetry is involved, try to do it via some visualization. Okay? Do not do it via Kirchhoff's laws. Usually Kirchhoff's laws is the lengthiest method. It's the last resort when nothing else is working. Then you have no other option then. Okay, cool. Let's go to the next question, guys. Coming up on your screen, here it is. Read it. Take your time. Read it. Touching a hemispherical dome or a tomb-like structure whose radius is r, radius r, there is a vertical tower. There is a vertical tower. You can see there is a vertical tower of height 4 times the radius. Height is 4 times the radius. This is r, 4 times capital R only. I think there is some printing mistake. Instead of small r, it should have been capital R. Yeah, this should have been capital R. And here also, I think this should not be there. Okay, now it sounds good. A boy projects a ball horizontally at some speed u from the top of the tower. So this tower is there whose height is 4 times of r. This person is throwing the ball with some speed u. The ball is striking the dome at a height of r by 2 from the ground. The ball strikes the dome at some height r by 2 from the ground. Okay. And rebounds, and after rebounding retraces back the same path and comes back into the hands of the person. What is the value of u? Crazy, guys. Just read the question again. Read the question again. This ball is being thrown, it hits the dome and it retraces the path and comes back into the hands of the person, and wherever that ball strikes on the dome, that height is basically r by 2. Okay, all this is given. Let's try to visualize this. Okay, perfect. Let's try, guys. All right. So what if we flatten the shape, can't we solve it like that? You can flatten the shape and solve it like that also. That is also perfectly fine. But it will involve one more step. Usually, if it is in 3D, if you are able to identify those points of symmetry, immediately tuck, 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 you will get rid of it. Or else trying to flatten it, again redrawing it takes some effort. Okay. So usually I try to avoid flattening method unless it is necessary and very complex problem. Okay. So let's see, guys, what do we do? Let me just visualize this. it is hitting at a height of r by 2 from the ground, is it? So let's say r by 2 from the ground means somewhere, let's say over here, that is where it is hitting, and it is half the radius. Oh my God, what is this? It is half the radius. So somewhere here maybe. And this ball is probably thrown with such a speed that, you know, it is going like this. Okay, it is falling over here. So it will fall over here. And when it falls over here, it has some velocity. That particular velocity will be probably like this. That velocity will be probably like this. Okay. And that velocity, let me call that as V. Okay. But one thing is there, whatever velocity was there initially, whatever velocity was there initially, which is u over here, that same velocity will be present here also, no doubt. That same velocity u will be present here also. If the speed initially was u will be there here also, because horizontal, horizontal, horizontal velocity is constant. And the reason for that, acceleration in the x direction is 0. That is the reason for that. Only the vertical component will arise. Obviously, the vertical component will arise like this. And let me call that as, let's say, for example, Vy. Okay, let's just call it as Vy. And maybe that thing is making some angle over here. I do not know what that angle is. I can call it as theta. Okay. Now, can I do something else with this? Maybe. Well, see guys, if this height is given, maybe geometrically we can find theta, and maybe this is the way to find theta. Observe this. If this is the dome, okay, and this is basically r by 2, okay, and we do not want this, okay. So this is the center of the dome. The radius of the dome is already given to me. It is basically r. So I'll just put r over here, and this is nothing but r by 2. This is nothing but r by 2. That is what is given to me. The ball strikes the dome at a height of r by 2 from the ground and rebounds back. Okay. So then if I draw the base over here, this is that base. Can I find out what that theta is? Maybe yes. If theta is the angle made with the horizontal, then over here, that same theta, that same theta will be basically this theta. Just check this out. This is going to be theta. Is that right? Because if this is theta, if this is theta, obviously alternate angles, this will be also theta. So from this, I can clearly see that sine of theta, which is opposite side, by hypotenuse, which is basically r, that will be half. Therefore, the value of theta will be 30 degrees. Great. I found out the value of theta, the angle at which it strikes. Now, the best part is when it strikes, it is going to rebound back. That means it was elastic collision and all of that. So, after after the collision, after the collision, again it will retrace back the same path. Okay, it is going to retrace the same path back. That means it was elastic collision. Only that way it will be able to what do you say, um, come back into the hands of the person. Also very important is, because it is retracing the same path, this particular velocity was actually perpendicular at this particular point. Yes, this velocity with which it strikes that dome, right, it was perpendicular, or else none of this was possible to be solved. And this velocity line, this line of velocity will be exactly along this particular line. Yes, this line of velocity will be exactly on this particular line. It will be perpendicular to that, circumference, or to that arc, or through that dome. Only when there is normal incidence will it be able to retrace back. Is this absolutely clear? If this is retracing back, the point of impact, the point of impact is perpendicular to the dome. Only then this is possible. Only then it will retrace it back. Okay, what next? The question was to find out the value of the speed. Let me use energy conservation and see what do we get. Here there is kinetic energy and potential energy. Here there is kinetic energy uh, completely, but speed u is still unknown. By energy conservation, I don't think we'll get it. But Vy we can find it using kinematic equations, because in the vertical direction there is only acceleration due to gravity. And if you notice clearly, how much height have you come down by? This is r by 2, this is 4r. So this much height by which you have come down is h minus r by 2, which is 4r minus r by 2, which is basically 7r by 2. So the height by which you have come down till here is nothing but 7r by 2. So let's use final velocity square is initial square plus 2 times acceleration times the displacement, third kinematic equation this is. So final speed, I do not know. Initial speed will be 0. Why? Why is it 0? Because it's horizontal. Plus 2 times acceleration due to gravity into height. Height is basically 7r by 2. Therefore, Vy will be nothing but root of 2 to cancel 7gr. Root of 7gr. Is this fine till here? Is this fine till here, everyone? So we know Vy. Do we know V, or do we need to know V? I don't think we need to know V, because I can use this angle information to solve the problem. Observe carefully. If I write maybe tan theta, yes, everything will be fine. Tan of theta, tan theta will be opposite side, which is nothing but Vy, by adjacent side, which is nothing but U. Therefore, U will be Vy divided by tan of theta. Therefore, U will be nothing but Vy. What is the value of Vy? It is nothing but, we just figured it out over here. It is the root of 7gr. What is the value of tan theta? Theta is nothing but 30 degrees. So tan 30 is nothing but 1 by root 3. 1 by root 3. So I can just put root of 1 by 3 also. It's one and the same thing. So that 3 goes on the top and we will get the value of u. If the 3 goes on the top, it will become root of 21 gr. Root of 21 gr should be the right answer. Let's check it out. Yes, root of 21 gr is the correct answer. So in this particular problem, energy conservation would not be even useful, because I do not know the speeds. What will I do with, energy conservation? I mean, the angle is given. I can't use the angle information in energy equation, because energy is a scalar quantity, so the direction is irrelevant and all of that. So we realized that because it is retracing the path, the velocity was perpendicular, and the moment the velocity is perpendicular, I showed that velocity, it will pass through the center, and then I resolved the components. I used geometrical information to find the angle at which it is hitting with respect to the whatever horizontal, and from that we found tan theta. Tan theta is nothing but opposite side, which is Vy, by adjacent side, which is u. So Vy was needed. So to find Vy, we found this. That's it. My job is done. Awesome question. Great. Yeah. Yeah. Uh, Sir, I considered r by 2 on the other side. Is that correct? Oh, that is a very good thing. Sir, what if I consider it on the other side? Say, for example, just show that diagram, because it was not mentioned in the question. You're right. What if somebody, I mean, there is nothing wrong, nothing correct, unless the diagram itself was explicitly mentioned. So let's say somebody takes it on the other side. What difference will it make? What difference will it make? Right? First of all, if you take it on the other side, tell me, can that particular ball ever hit and retrace back the same path? Can it ever retrace back the same path? It is never going to be possible. It is never going to be possible, because it has to hit perpendicular. So how is it that the ball will hit like this, perpendicular, and then go like this? Unless it's some Matrix movie or some, Rajnikant movie, then it is possible. I mean, where the bullet goes like this and comes like that. So then we will not study physics. Then we can do anything. It is imagination. We'll just sit over here, we'll chill out, and we can just, put some music on and we can just imagine whatever we want. So then there is no sense of it, correct? So on the other side, it won't be possible. So this won't happen. This won't happen. All right. So moving on to the next question on your screen, right? Beautiful question. Read this particular question, my dear students. AEEE also, okay, fine, noted, guys. Right, okay, no issues. We'll see. This particular question, there is a smooth piston of mass m and area of cross section A and is in equilibrium in a gas jar where the pressure of the gas is P naught. Find the angular frequency O of the piston assuming adiabatic changes of the state of the gas. Angular frequency oscillation. Okay. So what is happening? See, there is pressure outside, pressure inside. Equal pressure, so net force is 0. The piston is normal. But let's say I disturb it. That means I push the piston here. There are no springs attached, but the gas will get compressed. The moment it gets compressed, the pressure will increase. So the internal pressure will increase. So it will push the piston back. So when the piston starts going here, and once it crosses the equilibrium part, then when it goes on the other side, the gas would have expanded. Gas expands, the pressure will drop. So pressure inside is less, pressure outside is more. So the piston will start decelerating, stop, and because the outside pressure is more, it will again come back. So it will in a way oscillate because of the differences of the pressure involved of outside versus inside. Is this much understood? Is this much understood why it will even oscillate? Forget solving the problem. Moving the piston either left or right expands or compresses the gas, thereby reducing the pressure inside or increasing the pressure inside. But the outside atmospheric pressure will remain constant. So there is a pressure difference which is created, which will act like a restoring force. Okay. So let's think what will be the difference of pressure inside versus outside. Inside versus outside, what's the difference of the pressure? How do I know that? What is the difference of the pressure? Why is it coming? Because of changes in the volume. Oh, is pressure and volume related? Yes, they are. And that too, it is mentioned clearly. It is adiabatic process. And for an adiabatic process, for an adiabatic process, we know P into V raised to gamma is a constant. Now let's take derivatives on both sides. Yes, take derivative. So take d by, let's say with respect to time on both sides, d by dt. Okay, and see what exactly do you get if you take derivative on both sides. This is a UV rule type of question. So therefore, P into derivative of V raised to gamma with respect to dt plus V raised to gamma into dp by dt, constant's derivative is going to be 0. So this will be P into V raised to gamma's derivative will be gamma into V raised to gamma minus 1 into dV by dt using chain rule plus V raised to gamma into just dP by dt is equal to 0. Obviously, there is no role of now dt now, just get rid of it. Okay, dt will cancel. Next thing, what you can do is shift these people over there. Meanwhile, over here, P into gamma into V raised to gamma upon V is equal to, this will be minus V raised to gamma into dP. Now, what happens again is V raised to gamma and V raised to gamma will cancel out. Okay, so what we can say is that the value of dP is, take the negative on the other side, minus P into gamma divided by V. Just check this out, minus P gamma divided by V. And I think I forgot that dV. So sorry, that dV was also here. So this dV is also here. This dP is the change in the pressure. So that will also correspond to the excess pressure or the reduced pressure from outside versus inside. Therefore, the difference of the pressure, therefore, the difference of the pressure inside versus outside will be delta P, which will be negative P naught gamma divided by V naught, and this will be delta V. This will be delta V. P naught, V naught are the values of the pressures, and delta V is the change in the volume, gamma is the adiabatic ratio, delta P is the difference of the pressure. Now pressure is force by area, so why not write this as the difference of the forces divided by area is equal to minus P naught gamma divided by V naught. The volume change. See, if this piston moves over here, there will be a change in the volume. That delta V volume is nothing but area multiplied by the displacement. Area multiplied by the displacement. Area is, let's say, A, displacement is, let's say, X. Okay, so therefore delta F will become minus P naught gamma divided by V naught A square multiplied by X. Now let's understand what each sign means. This negative means that this force is a restoring force. It is a restoring force. That is very obvious. Also notice that our force is directly proportional to X. That means it is going to be a simple harmonic motion. It is going to be a simple harmonic motion. That means whatever is there over here, whatever is there here, the constant of multiplication, that is like your spring constant. That is like your spring constant. Therefore, omega being root of spring constant divided by m, it will be root of k, which is nothing but p naught, what is it? P naught gamma a square divided by v naught, whole thing divided by m. So therefore, omega will be, if you want, you can bring a outside, root of p naught gamma divided by v naught into m. So that is the value of the angular frequency. Yes, gamma p naught a square by m v naught. If you want, you can take a outside also. So this is the angular frequency of oscillation. Isn't it amazing? Yep. Very good. Awesome. If time period was asked, then also you can find it. It's not a big deal. But yeah, this is also straightforward. Okay. If omega is known, time period is 2 pi by omega. Okay. Beautiful question based on the concept of adiabatic process being PV raised to gamma, somehow related pressure and volume. So we related excess pressure with volume by taking derivatives, and we needed derivatives because how else will you find the small changes in the pressure? So that is the reason why I took derivatives in the first place. And then using the simple formulas, pressure is force by area, volume is area of cross section into the length or displacement. You find force is proportional to x, negative sign just signifies restoration. That's it. Immediately compare it with spring force formula. Force is minus kx, so k is nothing but this whole thing, spring constant. Okay, that's it. You'll get the answer. Moving on to the next question on your screen. There is a particle which is thrown from the surface of the earth with some speed equal to the escape speed. Okay, at 45 degrees with the horizontal. The angle of its velocity with the horizontal at height equal to r, where horizontal at some point means a line parallel to the tangent below the point is in degree. Interesting question, guys. This is going to be a very, very interesting question. Okay, let's get started. There is a particle which is thrown at an angle from the surface of the earth with a speed equal to the escape speed. Remember, escape speed is independent of the angle or the mass being thrown. So when you throw it at 45, 90, 20 degree, whatever degree, it will eventually exit the planet's gravity. But in the process of exiting the planet's gravity at some altitude, where the height is basically the radius of the earth. So after, it's like you have thrown a body and it is going out, and when the distance from the surface is r, then the line parallel to the tangent on the earth just below that point makes some angle with the velocity. Okay, let's draw the diagram. Only then we will understand it, guys, or else we will not understand it. Okay, there is this diagram here, but I doubt whether it is correct. Anyways, so we'll do one thing. So what is happening? I'll tell you. This, let's say, for example, even this is not needed. So let's say after moving some amount, this is like this. Here it was thrown with escape velocity. Here it has some another velocity. Let's say I call it u. Okay. The angle at which it was thrown, the angle at which it was thrown on the surface of the earth. Okay. This particular angle is given to be 45 degrees. 45 degrees with the surface of the earth. Okay. Now it starts going up. It is escaping, escaping, escaping. Somewhere in between the altitude is r. Then the velocity makes an angle with the tangent drawn to the surface of the earth below it. That is what is mentioned. Tangent drawn to the surface of the earth means like this. This velocity will make some angle. So that angle which we want to find is basically this. So what is this theta? They have asked. It's a beautiful question, guys. Are you now able to visualize it? Are you now able to visualize it? Guys, do you want us to solve a sample paper which was released by IIT Kanpur? Then definitely we will do it. Definitely we will do it next week in the coming few days. No worries. We'll do it. Okay. So how do we solve this particular question? Observe carefully. First of all, when you go from here to here, the angle may change, obviously because of gravitational force, but the force is not constant. Okay. Speed will also change. Maybe I will need the speed to find out that angle. But why I might need, I don't know. How do I find out the angle? Is it like the horizontal speed is constant? Lot of people have told me this. Sir, the horizontal speed will be constant. Is this true or false? Come on, guys. The horizontal component of the velocity will be constant. If that is the case, then escape velocity cos 45 should be equal to u cos theta. If I find u, I can find theta. V is known, cos 45 is known. Only question is what is u, so that I can find theta. Is this equation correct or wrong? Quickly tell me in the chat box. Quickly tell me in the chat box. The horizontal velocity is no. This is what many people think, but let me tell you, this is totally wrong, and there is a reason for that. I'll tell you why. This is very important for you to understand, my dear students. If you want, I'll waste one slide. It's okay. See, when the ground is flat, then when you throw a projectile, their horizontal speeds everywhere are going to be equal. This will be ux, ux, ux. This ux is constant, and the reasoning for that is because acceleration due to gravity is down like this. So there is no acceleration in the x direction. But realize one thing, that when the ground itself is curved like that, when the ground itself is curved like that, and you're throwing a projectile like this, saying that the horizontal velocity will remain constant, it is completely wrong. Because think about it, guys, the acceleration due to gravity will be like this over here. Over here, it will be at an angle. Over here, it will be at an angle. So for a large distance, saying that our horizontal velocity will be constant is wrong. Okay, so you cannot say all these things. This is definitely not correct. So this is for a long distance. For a long distance, g changes the direction. So that is the reason why this is not valid. Horizontal velocity. This is only valid. This is valid for short distance. For short distance only, because of the curvature of the earth. Because of the curvature of the earth. Is this absolutely clear, everyone, now? Great. Yes. Now, what else can we do then? Unexpectedly, something comes up. And what is that unexpected thing? See, the gravitational force on this point will be towards the center, here also towards the center, no matter where it is towards the center. The gravitational force passes through the center of the earth, passes through the center of the earth. So if I ask you what is the torque of the gravity about the center of the earth, the answer will be always a zero, because torque is R cross F. If the force is passing through the axis, no matter what R is, what F is, you will never be able to generate any torque. They will be anti-parallel to each other. So answer will be zero. That means the angular momentum is going to be conserved. The angular momentum is going to be conserved. That is the trick involved over here. Isn't it crazy, guys? The angular momentum, yes, you heard it right. The angular momentum is going to be conserved. Wow, crazy. So what is the angular momentum initially versus angular momentum finally? If you notice, initial angular momentum will be mass. Do not take the vertical component, take only this component. So VE cos 45 multiplied by distance. Distance is basically R only. Later on, the angular momentum will be mass into velocity. Do not take this component, only take the perpendicular component, so which is u cos theta. So u cos theta multiplied by the distance, which is nothing but 2r. That is what it is. Is this absolutely understood? So angular momentum conservation is involved over here in this particular question, which is a beautiful, beautiful aspect. Very tricky to think, guys. Very unexpected. Mass gets cancelled, R gets cancelled, and escape velocity, well, do I know it? Of course, it is a root of 2 times gm divided by r. Cos 45 is 1 by root 2. This is going to be equal to u. I do not know yet, so I'll just leave it as it is. I'll put cos theta over here multiplied by 2. So somehow I need the value of u. I need the value of u. For that, I need energy conservation. For that, I need energy conservation. So conserving energy, conserve energy, mechanical energy, kinetic plus potential. So what is the initial energy? What is the final energy? Let's try to think. Here, it has kinetic and gravitational potential energy. So kinetic energy will be half m escape velocity, which is root of 2 gm divided by r, the whole square, minus gmm divided by r. This is potential energy. This was kinetic energy. Kinetic energy because of the escape speed, potential energy because of the separation, is equal to, when it reaches the top, the kinetic energy will be just half mu square irrespective of theta. It is a scalar quantity. Gravitational energy will be negative, so minus gmm by 2r. So minus gmm divided by 2r. Okay, I want half mu square, by the way. So half mu square will be, take this gmm by 2r on this side, and on this side, what do we have? This 2 will cancel, okay, and this will become gmm divided by r minus gmm divided by r again. Just check this out. Is this right, everyone? And we have over here this one as plus, because from minus it became plus. These both just got cancelled, so I am just left with only this. So half mu square is gmm divided by 2r. 2 mm cancels, so u square is equal to gm by r. Therefore, u is equal to root of gm by r. So u is the root gm by r. So substitute it over here, root gm divided by r. I just substituted the value of u. Okay, so we just need theta over here. Many things might get cancelled. Let's see what are those things. First of all, this root 2 and this 2. This gm by r, this gm by r. Okay, very simple, guys. Now very small things are remaining. Therefore 1 is equal to 2 cos theta. Therefore cos theta is equal to half. Therefore theta is equal to 60 degree. So the answer is 60 degree. Let's figure it out. Oh yes, it is 60 degree, guys. Perfect. It is 60 degree. So the concept that you learned here is whenever you have these kind of problems where the heights ranges are very large, then the horizontal speeds are not constant. Rather, the angular momentum is conserved because the gravitational pull is always towards the center of the earth. That creates no torque, means angular momentum is conserved. So apply conservation principle at both the places, and if needed, use energy principle for additional values. Cool. Did you love it? Yes, MR Skull will be solving that paper of IIT Kanpur. I'm so glad Nurture and Pathfinder are very useful for all of you, and they created those sessions with lot of dedication so that you guys understand it very nicely. Great, guys. Moving on. Moving on to the next question. This is also amazing question. Wow, we have prism and I can see a big paragraph, and I don't like some angles out here like 6 degrees 30 minutes. Wow, crazy, guys. Let's see what is this question. Question is to find the refractive index of the prism. There is a parallel beam of light which falls normally. See this. This is a beam of light which is falling normally, that means perpendicular. It goes inside at the first phase with a small angle of prism. Oh, the angle of the prism is given to be very small. Okay, great. At the second surface, it is partially transmitted and reflected. So as it goes inside, it will not refract at all because it is normal incidence. It goes inside, the angle of prism is very small. On the other side, it gets partially reflected, partially refracted. That means some of the rays will come out, some of the rays will go back and again hit the first surface over here. And again, when they hit the first surface, again they are going to come out. Are you able to visualize this till this point? Yeah. So goes in, goes out, and also partially reflects. So some is reflected, some is transmitted. Okay. And emerges from it in a direction, making an angle 6 degrees 30 minutes means 6.5 degrees. Remember, 60 minutes is a degree, just like the hands of your clock, like same way. So 60 minutes is considered as 1 degree. Okay, keep that in mind. All right. With the reversed direction of the incident beam. Oh, what the hell is this? Incident beam, reversed direction. That means instead of going like this, it is going like this. So with that, the emergent beam is making an angle of 6 degrees, 6.5 degrees. The refracted beam has undergone a deviation of 1.15 degrees from the original direction. Remember, the light which was incident gets partially reflected and refracted. This has deviated by 1 degree 15 minutes from the original direction. Find the refractive index of the glass. Okay, cool. Let's see what can we do. Now, see, first of all, the original beam of light is falling like this. It is having a normal incidence. Yes, it is having a normal incidence. So it will continue its journey as it is. It will hit over here. It will hit over here. Let's only talk about the refracted ray for now. Let's only talk about the refracted ray for now. So this is the light which is just purely getting refracted. That's it, not reflected. And there is a deviation over there. Let's say that deviation is basically delta. This angle of prism is given to be very, very small. This angle of prism is given to be very small. And as you can see over here, there are internal angles also, if you remember. Yep, internal angles also. Yes, it is 90 degree, but that internal angle over here, R1 will be 0. Remember, internal angles R1, R2 are there. Here, that internal angle with the normal, I do not know what it is, but I will call it as R for now. It is R2. And we all know that the angle of prism is nothing but R1 plus R2. This being 0. Why? Because of normal incidence. So whenever there is normal incidence, don't take the angle of incidence as 90. It is 0. This is a common mistake. Silly mistake rather. Many students do that. Be careful. It is 0 degrees. So therefore, the value of R2 I am getting it as the angle of prism itself. That is what it is. Okay, number one. Deviation, well, I know there is a formula for deviation, guys. What's the formula for deviation for a thin prism? It is nothing but angle of prism into mu minus 1. But the problem is I do not know A. Okay. Is the deviation given to me? Yes, I think so. It is 1 degree 15 minutes. 1 degree 15 minutes. So, deviation being 1 degree 15 minutes is 1 degree 15 minutes. Guys, 60 minutes make a degree. 15 minutes is 1/4 of a degree. So 1 degree plus 15 by 60 of the degree, which is 1/4 of the degree. So 1/4 of the degree, which is nothing but 1.25 degrees. And usually we will need it in radians also sometimes. So we know how to convert that. So keeping all these aspects in mind, I can just say that deviation being angle of prism into mu minus 1, 1.25 degrees is angle of prism into mu minus 1. If I somehow find A, my job is done, but A is R2, but I do not know R2. Oh my God, we are in a complete soup. I need to know A to find mu because the question was that find the refractive index. How do I find the angle of prism? How do I find R2? That is the next thing that should run on your minds. Okay. Now let's see if something else is given to us. Maybe there is over here. Yes, we did not use this fact that the emergent ray is making an angle of 6 degrees 30 minutes, which is basically 6.5 degrees, because 30 minutes is half of 60 minutes. So it is 6.5 degree or 6.5 degrees with the reverse direction of the incident beam. Okay. Well. If I draw a normal over here, this will be parallel to the incident direction, and then this will be the reversed direction of the incident ray. This will be reversed of incident, reversed of the incident ray. This is your incident beam of light, and that obviously is making 90 degrees. And your emergent ray is right over here. This is your emergent ray, which is after the reflection coming like this. We know that during reflection, angle of incidence is angle of reflection. So if this is R2, this is also R2. So the total angle that is formed over here, is basically 2 times of R2. Can you see that? Between this and this is nothing but 2R2. Everyone? Now, do you see two parallel lines and an intersect? Are you able to see two parallel lines and an intersect? Alternate angles are equal. So, meaning this particular angle over here will be 2 times R2, will be 2 times of R2. See if this is okay for all of you. This will be 2 times of R2. Everybody with me? I'm so glad, Sai. It is making you think very deep. Yes, very true. And I love these sessions. Trust me. I never, there are certain sessions where I think about, whether students are watching, not watching. But these are sessions where I'm doing it more like for myself because I love physics and, solving these problems, just keeps my brain very active. So it is fun doing these problems. Trust me. Okay. So if this is a 2R2 and this angle is given to me, it is 6.5 degrees. Oh, let me use Snell's law, guys. Let me use Snell's law. This angle is given to be 6.5 degrees. I have to use Snell's law, no other option. So using Snell's law, sine of 6.5 degrees divided by sine of 2R2, which is the angle of refraction inside, will be the refractive index. Shifting it, I will get sine of 6.5 degrees, I will convert it into radians, which is pi by 180, is mu times sine of 2 times R2. Usually all angles are kept in radians. This angle is very small. 6.5 degrees is very small angle, guys. You can use small angle approximation, especially when it is in radians only. Don't say sine of 6.5 is 6.5 because 6.5 is small angle. No, it is only when converted into radians. That's why I have done that. So 6.5 multiplied by pi divided by 180 is approximately equal to mu times of 2 multiplied by R2. But wait a minute, R2 was just found out to be A. I just told you this value of R2, this value of R2 is nothing but A. So just put A over here as it is. Okay, this 2 will shift it below, no issues. So mu times of A. So this will become 6.5 pi. This 2 multiplied by 180 is nothing but 360. So mu times A 6.5 pi divided by 360. I think I'm getting some ideas now. And one such idea is, look at this. This is in degrees. Why not convert it into radians? So 1.25 multiplied by pi divided by 180. Okay. Just converting this degrees into radians because everything is in radians here is equal to a mu. Just check this out. A mu minus a mu minus a. Oh, we know what to do next. Therefore 1.25 pi divided by 180 is equal to a mu is nothing but this number right over here, which is 6.5 pi divided by 360. Okay, minus this number a, minus this number a. Okay, so therefore from this a will be this minus this. Yep, this minus this. So we will have 6.5 pi divided by 360 as it is, and this will go on this side, guys. This will go on this side, but keep the denominator same. So I will make it 360 over here, and this will become 2.5 so that I can subtract easily. Yeah, I just converted 180 into 360. 1.25 into 2 becomes 2.5. So 6.5 minus 1.5, what will it be? 4. So it will become 4 pi by 360, which is basically pi by 90 degree, which is nothing but pi by 90 degree, which if you convert it into degree, pi by 90, sorry, not degree, radian. And if you convert it into degree, it will be pi by 90. This you multiply by 180 divided by 5 in degrees. So pi cancels. This will be nothing but 2 degrees. Okay. Angle of prism is 2 degree. My job is done. Yes, the next step, guys. 2 degrees into mu minus 1. This is 1.25. So this will become 0.625 is equal to mu minus 1. Is it? And therefore, mu will be 1 plus 0.625. Therefore, mu will be 1.625. That is the final answer. Mu will be 1.625. Yes, 1.625. Perfecto. Perfecto. That is the right answer, guys. We have found it out. So, beautiful question on mathematical manipulation and approximations. Geometry involved like hell and crazy. Visualizations needed and lot of prism formulas like this one or even the Snell's law or the angle of deviation formula for thin prism. All these knowledges, all this thing was needed. Beautiful, guys. Also, we are converting sine to r into 2r. Yeah. No, this r was always in radian. So we have never considered r in degrees here in this entire problem. So I'm considering this in radian already. I'm considering this in radian already. Okay, so that's why I did not convert it. Okay, is that clear? It's not minimum deviation. Yes, nowhere did we use minimum deviation formula. Tell me, where have I used minimum deviation? And this formula for a thin prism is not always for minimum. It is for all the deviations because it is a thin prism. Getting my point? Yeah. And I did not use that formula mu is sine of a plus delta by 2 by sine of a by 2. Why I can't do that? Because who says this deviation is minimum? Got it? So that's why I didn't use that. That big formula is there, no? Mu is sine a plus d by 2 by sine of a by 2. Why I didn't use it? Number one, the angle is small. Number two, it's not even minimum deviation. The delta over there is minimum deviation. Cool? Tejit, Gaming, everyone. Unknown, Sai, Vivid, Ramu, everyone, guys. Siva, loved the question. Shall we go ahead? Shall we go ahead to the next question, my dear students? Yeah. Okay. So keep in mind, for thin prisms, this is not delta minimum. This is general delta, all the deltas. In fact, for a thin prism, keep in mind, the deviation is so small, you can't differentiate between minimum deviation and normal deviation. So you approximately say minimum deviation is usual delta, general delta. That is why this formula is not exact. It is also an approximate formula, only for thin prisms, not for general prisms. Okay, perfecto. Let's go to the next question, guys, coming up on your screen. And here it is. And if you are loving the questions, smash the like button. I find it very hard to digest the fact that JEE Advanced students find it like as if you are paying money when you are liking the session. Other sessions, VIT triple E, BitSat, this, that, so many likes will come. For advanced, no, I am IIT and I will not like anything. I have to see Nobel laureate in the front of the screen, then only I will appreciate the video. Guys, sorry, no Nobel laureate is going to come and teach you for IIT JEE. If it happens, I would be very happy, but sorry guys, I did not win Nobel prizes. So whatever I am, just smash that like button for me. Okay, cool. In a region, magnetic field along the positive x-axis changes with the time according to the given graph. Magnetic field along the x-axis changes with time according to the given graph. A positively charged particle is projected from the origin at an angle theta with the positive x-axis in the first quadrant of x dash y plane. Ayo, x dash means not the dash, like the dash literal xy plane. We write right like this xy plane. I think it was literally typed over here. Okay. If the time period, pitch, and the radius of the helical path are t naught, p naught, and r naught respectively, which of the following statement is correct? The magnetic field is once this way, then reverses. This way, then reverses. This way, then reverses. Yep. Okay. The maximum distance of the charge from the x-axis is 2r naught or 4r naught. At this times, the charge's coordinates are, wow, crazy guys. This is going to be crazy. Okay. Sir, how we got this formula? By simplifying that minimum. Yes, Tejit, we got it by simplifying that minimum deviation formula and then equating it to the approximation saying delta minimum approximately equals delta for small a. So that is how you eventually get this formula. Okay, from minimum deviation only you get it, but for thin physics, minimum deviation is delta approximately. Okay, so let's understand. Magnetic field is in the x-axis. The particle is thrown, making an angle with the x-axis in the xy plane. So it will obviously go in a helical path. Now, see, this is a very weird problem. I'll tell you why. See, guys. First of all, our magnetic field. Let's take it here. And then slowly the magnetic field will be here. Wow. The magnetic field is going to change the directions continuously. So first, the magnetic field will be here. So B naught I cap. Then the magnetic field will like this minus B naught I cap. So if you are throwing the particle like this, making some angle, let's say V naught, it will go like this in a helical path. Yeah, it will be a helical path. But just imagine the particle completes one revolution, and that is what is happening over here. After one time period, what is this T naught? It is the time period of revolution. Exactly after one revolution, exactly after one revolution, that is very interesting. Exactly after one revolution, okay, the magnetic field is reversing. The magnetic field is basically reversing. So it is going in a different helix then. Oh my God, this is crazy. So to visualize this, it is better that instead of this diagram, let me see what is happening in the other directions. So see guys, this is the y-axis and this is the z-axis. Let me show that. This is I cap, right? This was y-axis, this was z-axis. If you ask me, show me what is exactly happening from the front view, show me exactly what is happening from the front view. It will be something like this. Okay, this is your z, this is your y. Towards you is basically the x-axis. Towards you is basically the x-axis. Keep this in mind. Okay, towards you is basically the x-axis. Like this. I'm seeing it from the front. I'm seeing it from here. Y is on the top. Z is towards my left side. Z is towards my left side. That is what has happened. So the velocity will have components Vy and Vx, and you will see the particle going in a circular path like this, and that circle is coming closer to you. Is that right? Everyone, you are going to see it going in a circle, but it is coming in front. It is coming in front. It is coming in front, but the projection is a circle. Are you able to visualize it? Everybody? Okay. But then what is happening? Once it completes a revolution, just imagine this. It is going here, it reaches here, it reaches here, and reaches here. It starts from, it basically starts from, my dear, it starts from t is equal to 0. It reaches here at t is equal to complete time period by 2. And it comes back here at t is equal to t naught. Exactly at t naught, a very strange thing happens. The magnetic field has reversed in direction. So what will happen if the magnetic field reverses in direction? This circular path will now be over here. It will not go like this. It will come here. It's crazy to visualize that now the particle is going to go like this, like this, like this, and like this. So at t is equal to t naught, at t is equal to t naught, it has basically switched on to a newer circle. It goes like this, and maybe this will be t is equal to 3 t naught by 2. It will come like this and reach over here at t is equal to 2 t naught. T is equal to 2 t naught. At 2 t naught, what is happening? At 2 t naught, magnetic field is again reversing. So now it will go on to this circle. So just imagine this. The particle is going like this, then switches over to this circle, then again switches over to this circle, again switches over to this circle, all while, all while coming in the front. Crazy to visualize. I can't even draw. I'm so sorry. It's very difficult for me to draw this. Okay, so I'll just make you visualize as much as possible. The particle goes like this while coming in the front. So that's why I'm moving in the front. Observe me. The particle goes like this, reaches here, switches the circle, goes like this in a dual helix. Again like this, again like this. A dual helix is formed. A dual helix is formed. It is crazy to think even about it. So it goes like this maybe. And then it goes like this towards here. Something, I don't know. It's very difficult to visualize it. I don't know. How do I even draw it, guys? Like this. And then again, it will go on to this helix. Sorry, it will again go on to this helix. And again, it will go on to, you know, this particular helix. So it's a crazy diagram to visualize. Okay, it is going to go on to this like this. Just try to visualize, guys. Okay, that is what is going to happen. This is a dual helix. Are you able to visualize? Yes or no? Are you able to visualize? Okay. So now think, I think one of the options mentioned over here was, where is it? The maximum distance of the charge from the x-axis, from the x-axis X-axis is towards you. From the X-axis, it can go here, it can go here. What is this distance, guys? What is this distance? If this is obviously R0, this will be 2R0 on this side, or even on this side. This will be also 2R0. Are you able to visualize this? Because the radius of the circle will be R0. So maximum distance is 2R0. So not 4R0. So hence, this is correct. This is absolutely wrong. This is absolutely wrong. So C is correct. A is wrong. Everyone till this point absolutely clear? Okay. Perfecto. Now let's go to the next point. T0 by 2 and 3 T0 by 2. I had kept these values in my mind. So deliberately what I did is I mentioned those points here. T0 by 2 and 3 T0 by 2. Now be very careful, okay? T0 by 2. T0 by 2, you are here. Check what is the coordinates, okay, at T0 by 2. Check what is the y coordinate. Y coordinate is 0. So there will be three coordinates. There will be three coordinates. Three coordinates, correct? So you have your x coordinate, you have your y coordinate, and your z coordinate. Observe carefully. Which you know, this is at this point, guys, T0 by 2. T0 by 2. Obviously, the y coordinate is 0. So put 0 over here. This is the z coordinate. It is on the negative z direction, not on the positive z. So negative z direction. So that's why it should be minus 2r0, negative 2r0 for the z coordinate. But what about the x coordinate? Remember, it was coming with a constant speed, and in one revolution it moves pitch. In one revolution it will move the pitch distance, whatever is the pitch. P0 is the pitch. So in one revolution, the distance along the x-axis is basically P0. So in half a revolution, the distance which is along the x-axis will obviously be P0 by 2. Will obviously be P0 by 2. So think about it. In this particular part, the x coordinate would have gradually incremented by a value of P0 by 2. So P0 by 2, 0 minus 2R0. P0 by 2, 0 minus 2R0. Perfectly correct, guys. D is absolutely correct. Let's go to B option. That is at 3 T0 by 2. B option is 3 T0 by 2. Let's see what the coordinates are quickly. So I'll put comma, comma, and over here. And we are interested in x coordinate, y coordinate, and z coordinate. The y coordinate is absolutely clear at this particular point. It is on 0 coordinate y-wise. Y-axis wise, it has 0 coordinate. X coordinate, sorry, z coordinate, can you see? It is over here at a distance of positive 2r0. So plus 2r0 right over here. What about the pitch, which will help me with the x-axis coordinate? The x-axis coordinate, visualize this. One revolution done, P0 distance went ahead. So after more half a revolution, how much more distance will it go? More P0 by 2. So P0 by 2, P0 by 2, P0 by 2. So essentially, I can say that in 1.5 revolution, the distance which it moves along the x-axis will be P0 plus P0 by 2. 1.5 means 1.5. So it will be nothing but 3 P0 by 2. So hence, this particular answer will be 3 P0 divided by 2. So let's see whether it is there. 3 P0 by 2, 0, 2 R0, absolutely correct. So B, C, and D is the correct answer. B, C, and D. Perfect, guys. B, C, and D is the absolutely correct answer, as you can see over here. What a visualization. I mean, who would have thought of a double helix because of a square-waved magnetic field? Square-waved magnetic field creating a double helical problem where the particle is, it starts here. Just visualize it. Okay, just close your eyes and visualize after I show you. It goes like this, comes here, and then goes like this and comes here, and then goes like this and comes here, and then goes like this and comes here. And it is making that beautiful infinity-like symbol. Yeah, or just how you move your swords in fighting. So it is going exactly like this. Just imagine a swordsman doing this action as he is raging towards the enemy. It's exactly the motion what the particle is doing. A swordsman, making these hand movements and going like this, that's exactly the motion being encountered in this particular problem. So beautiful. If this problem ain't exciting you, then nothing will. Okay, then I don't think you should study JEE Advanced Physics. If this problem did not uh, make you like this video, I think nothing else will make you like any other video. Okay, great. So that's it. I think because there is a homework question after this. This homework question is also nice question. Please try to solve it. The solution is there on the next slide with the answer key. I will not show it to you. Options are there over here. Okay. So about the electric field potential and all of that, it is again based on symmetry. You will definitely be able to solve it. Okay. Solution and answer key is there on the next slide. Now, please remember we'll be coming to Chennai 6th May. That's this Tuesday in the evening. So if you have not yet filled the forms, please fill the form. The link should be there in the description box of maybe either this video or some other video as well. I had made a, see this. Restart your JEE Dream in Chennai. So if you are around Chennai also, please come down. We can meet. This is for all the students who are going to give the JEE in the next year or who are passing out and want to get some career counseling. So this is for all the students out there. JEE, NEET, everything. Okay. So I'll love to meet all of you. The entire team will be there. You can mention all your details because we have to reserve seats and classrooms. It's not like we have too much of space there. So please make sure that you reserve your seat by registering for the event. Okay. Thank you so much. I'll be solving the sample paper also, which was released by IIT Kanpur very soon. Okay. Bye-bye. Take care. Have a great time. Thank you for liking and subscribing.